Hi all, today we're gonna attempt another problem solving related to an equilibrium of a uniform rigid body. A traffic light hangs from a structure as shown in figure 8.14. The uniform aluminum pole AB is 7.5 meter long, has a mass of 8.0 kilogram. The mass of the traffic light is 12.0 kilogram. Determine A. The tension in the horizontal massless cable CD. B. The vertical and horizontal components of the force exerted by the pivot A on the aluminum pole and the total force. For the step 1, let us draw all the directions of the gravitational force vertically downwards, so called weight. Traffic light as weight T. Weight of the uniform aluminum pole at center of gravity. This is the uniform aluminum pole. Center of gravity. The direction of the weight. As weight pole. All these gravitational force, so called weight, acting below the uniform aluminum pole. Above the uniform aluminum pole, we have another force as the tension in the horizontal massless cable CD. Take the moment at A, and A gonna be the axis of rotation. So torque clockwise equals to torque anti-clockwise. For the clockwise direction, we have two turning effects. One is weight of traffic, another one is weight of pole. For the clockwise direction, the weight of traffic times the perpendicular distance from the axis of rotation. So it is the weight of traffic, perpendicular distance from the axis of rotation. We take it as xt. Again, for the clockwise direction, the weight of pole times perpendicular distance from the axis of rotation. It is from weight of pole to the axis of rotation. We take it as xp, whereas torque for anti-clockwise direction, the only force tension of the cable times perpendicular distance of 3.8 meter. Perpendicular distance of 3.8 meter. So for clockwise direction, weight T times xt plus weight P, weight of pole, times xp, the perpendicular distance, equals to torque of anticlockwise, the tension of the cable, times the perpendicular distance, 3.8 meter. So we have to find the xt and xp to get the tension of the cable. Mathematically, these two angles are same. To find xt, we can use cos 37 degree equals to xt divided by 7.5 meter. 7.5 meter is the length of the uniform aluminum pole, which is A to B. So by pressing the calculator, cos 37 times 7.5 equals to 5.99 meter. If you don't have calculator, calculate later. For xp, it's the distance from the center of gravity. So xt, which we got it just now, xt divided by 2. So the xp is equals to 2.99 meter. So now we can easily solve the problem. Mass of traffic times gravity times the xt plus mass of pole times gravity times xp equals to tension times 3.8. Mass of traffic is 12.0 kilogram. It is given value. Mass of pole is 8.0 kilogram, also given value in the question. 12.0 times 9.81 times xt. Xt is 5.99 plus MP is 8 kilogram times 9.81 times xp is 2.99 equals to T times 3.8. So we're going to press the calculator. 12 times 9.81 times 5.99 plus 8 times 9.81 times 2.99 divided by 3.8. So the tension of the cable is 247.3 Newton, or you can put it as a tension is 247 Newton. For section B, the vertical and horizontal components of the force exerted by the pivot A on the aluminum pole and the total force. So the vertical force should be Fy, and the horizontal force should be Fx. For the vertical component, we can draw the free body diagram to show all the forces acting vertically. So this is the pole of AB. So the force, the vertical force is Fy. Another vertical force vertically downwards, rate of 4, and another vertically downwards force. Wait for the traffic, wait for the pole. So Fy equals to weight of pole plus weight of traffic light, equals to 8 gravity plus 12 gravity. 8 gravity plus 12 gravity, you will get 20 gravity, which is equals to 196.2 Newton. This is for vertical component. So this is for vertical components. For the horizontal component, the Fx is equals to the tension of the cable. So Fx equals to tension of the cable, which is equals to, what is the tension of the cable? It's 247.3 Newton. So answer is 247.3 Newton. That's it. Simple like a bubble, without giving you any trouble. The last part is about total force. The total force is the resultant force which is acting between Fy and Fx. So this is gonna be the resultant force. By using this formula, you're going to find the resultant force at point A. By substitute the Fx and Fy, you will able to get the resultant force, which is equals to 315 Newton. 315 Newton. Answers are given. So the battle is settled. Thank you for watching this video. Thanks a lot and thank you to the lot.